All right, guys, you're welcome to the 38th question of this challenge, and we are still solving problems on differentiation. Here's another exciting problem we want to solve, and of course, we're going to show you how to go about this problem one step at a time. So, guys, if you've been following this video consistently, you will definitely see that this particular question is very similar to the previous one we solved on question 37. But why do we have to bring this stuff for you? Just for you to understand some basic things that most students might overlook and they will miss the answer. So guys, you just have to stay to the end of this video and get the entire value we have for you. So let us get started with this particular one. So we have, if y is equal to 2 upon the square root of 1 plus x squared, we are trying to find the derivative of y with respect to x. In other words, we want to differentiate this function once with respect to x. So the very first thing I would like you to remember is the square root function. If you have square root of x, you can decide to express this as x to the 1 over 2. If you have cube root of x, you can go ahead and say this is x to the 1 over 3. Like that, you can just continue like that, okay? And one other thing again you should know is if you have 1 over x is the same as x to the negative 1. If you have 1 over x squared, for instance, is the same as what? X to the negative 2. So you can just continue like that. All of these things is what we need in solving this particular problem. So let us go right into this one. So the very first thing I want you to look out for is this. Let me show you some stuff here. If I have 2 over 5, this is the same thing as writing 2 times 1 over 5. I mean, like you can just bring out the 2, so you kind of have it 2 times 1 over 5. Does it make sense? Because this is the same as 2 over 5. So this guy is going to be like 2 times 1 over the square root of 1 plus x squared. Perfect. And that makes a lot of sense to us, right? Because this is now the same as 2 times 1 over 1 plus x squared to the 1 over 2. Remember, we've talked about how we can get rid of the square root function. I mean, how we can get rid of the root function, how we can transform root function to index expressions. Like I've just showed you here how to go about it. So that is pretty clear. So from this very point, what else can we do? We can still go further to say that if you have 1 over x, you know how to put this stuff in index form. So this expression is still going to become 2 times 1 plus x squared all to the negative 1 over 2. So this is quite easy. We are just applying the exponential rules, or what you call the laws of indices. So to this very point, we can easily just differentiate this function applying the chain rule. Does it make sense? Yeah, I'm very sure it does. So now let us go ahead and differentiate this function. Now I have y is equal to 2 into 1 plus x squared times negative 1 over 2. You know how to go about the chain rule. If this is your first time seeing us in this very space, we've already started a long time ago. So the best thing I would advise you to do is to go watch the previous videos on differentiation. That is question 20. That is where we start differentiation. The very first question was on logarithm. So just follow the series and I'm sure you're going to find value, because we've already done a lot of stuff here and we are building on the previous stuff we discussed. So differentiating this, guys, you know how we do it, guys. So that will become the y dx is now equal to this guy multiplies the base. So that's like minus 1 over 2 times the 2 we have here, of course, with the base, which is 1 plus x squared. Then the next thing we do is to remove 1 from this power, and minus half minus 1 is minus 3 over 2. So that is simply addition or subtraction of fraction. That's quite easy. But that is not all. The next thing we're going to do is to differentiate the inner function. That is this guy's right here, not the 2. I mean the inner function. So when you differentiate 1, you get 0. When you differentiate x squared, you get what? 2x. Yeah, so to this very point, I'm very sure this is really clear. So let us go ahead and clean up all of these expressions. Let us clean them up. You can see clearly that these 2 can take away these 2. And now we just have negative 1 plus x squared to the negative 3 over 2 times 2x, right? And we can go ahead and distribute to this point. So we have it as negative 2x times 1 plus x squared to the negative 3 over 2. I'm really just doing this stuff step by step, but I'm sure if you've been following this video, you can actually skip most of the things I'm doing here. I'm just doing this for explanation's sake. Okay. So now the next thing is you can also find your answer in this form. This is a possible answer, but somehow the JAMB body might decide to extend the simplification further. So what I'm trying to say is that we can still go further to express this solution. So that's going to be like saying minus 2x. Remember, if you want to get rid of this negative exponent, you see how we go about it. That becomes 1 over 1 plus x squared all to the positive 3 over 2. At this point, we've gotten rid of the negative exponent, right? So you can still go ahead and say this is the same as multiplying out. You have negative 2x all upon 1 plus x squared all to the 3 over 2. This is a possible answer. This could be your dy dx. And again, they might also go further to tell you that you can still simplify this expression further, and that becomes negative 2x upon the square root of 1 plus x squared all to the power 3. I explained all this stuff in the previous video, so this is super clear, and I'm sure you found value from this very video. If you did, kindly let us know in the comment section. Give us a thumbs up. I mean, share this video to other learners, and that is just one way to appreciate us. So guys, I wish you guys all the best in your preparation, and I can't wait to see you in the next video challenge. So have a wonderful day and God bless you. Bye.